So the question said the parents have agreed to buy her tickets to see her favorite band, right? If she spends average 10 hours per week. So she needs to like spend 10 hours per week average, right? And for 6 weeks. Okay, so if you're like told the average, which is 10 hours per week, and the first 5 weeks she have around this many hours. So we are gonna add these guys. So the 8, 11, like 7, and 12, 10. So these are the first 5. And then let's say the 6th week, she have X hours. So when you are looking for the average, we just add them and divide by the number of like stuff, which is number of numbers in this case. And then this is gonna give us the 10 because that's the average. And then we are gonna solve this equation. If I add these guys, so let's say these two 20, and then these two is 18, that's 38 and 48. So I can say that's 48 plus X. If you multiply both sides by 6, so you should get 60. So they subtract 48 from both sides. So we got 12. Okay, so that is the correct answer. So one way to look at it is basically just add them and divide by the number of integer. So that's what we just did. Since another way we can take a look at this problem is like, since we are told the average is 10 hours, right? So maybe we can use that in a different way to get what we want. Like this is kind of straightforward approach. I get it. So everyone can do this way. But I kind of like the second approach where we can compare these numbers compared to the average. So when we say average, the average is just sometimes higher than some of the values, and then sometimes lower than some of those values. But as average, the 10 is the midpoint, right? So then if that's the case, we are gonna take the 10 as a balancing value. So what I mean by that, so if you are writing the values, let's say 8, 11, like 7, 12, and 10, so there will be one last number. So this 8 is 2 lesser than the average. 11 is 1 more than the average. 7 is 3 lesser than the average. 12 is 2 more than the average. This is exactly the average, so there's no difference. And when you add these guys with the last number, you should be getting 0 because the average will become a 10. So if you add like 2's, that is 0. So you get 1 minus 3, which is -2. You know, for us to get this sum to be 0, this -2, when you add these, you get -2. So you should have a positive, like you should add a +2 so we can get the sum of these values, sum of differences to be 0. So whenever we are gonna get a +2, so since the average is 2, so if you add 10, like 2 to 10, so you get as 12 as well. So the second approach I don't like much than like the first approach, especially if the numbers are huge values. So let's say we are told the average is 10,000, right? And then the other number is 999, 995, and I don't know, 10,002, like 9,000, whatever. So if you are given a big values, then I probably choose the second approach to do this one because I don't want to add those huge values. I just need to know the missing numbers to get that average. So I hope that makes sense. Okay. So the second approach will be useful in some cases. I'll show you when this is actually much better to use. Okay. So that was, so we are told there are 650 students who were surveyed about their choices, right? And then the options are given. There are 4 choices. And what would be the ratio of the number of students who prefer spaghetti? So if you look at the, so that's the one we are concerned first. So that is exactly to 50 to the number of students who prefer this one, right? So that is at this level, so which is just 100. So the we are looking for the ratio of this number to this number. So we want to be careful. So that should be 250 over 100. So cancel these guys. So you can still divide by 5. So that should be 5 and 2. And that is our answer. So if I show you the choices, the choice A is 2 over 5. But this is our answer is 5 over 2. Okay. So what I mean by that, like sometimes you have to be careful. So because you're gonna always given some like choices, that will be distraction. So in this case, choice A is 2 over 5, choice E is 5 over 2, so E is the answer. Great, so here's the next one. Oh, like some of the two smallest prime factors of 250. So the prime factorization is really a powerful tool, and some people use factor 3. So I don't like using the factor 3. So I just use the divisibility rules immediately. So when you look at the 250, so it's obvious that's 25 times 10, and then 25 is 5 squared. And then 10 is 2 times 5. So if I combine 5, so we have 2 5s and 1 5, so which is 3 5s, and then 1 2. So this is my prime factorization. But the question says, find the sum of the two smallest prime factors. Like prime factor means like the number that is going to be a prime and also divisor out to 50. So we already have only two prime number as a factor. So if you remember, like prime number was the number that is divisible by only two numbers, the number itself and 1. So 2 and 5 are the two prime numbers in our numbers anyway. So there is no such other like our prime numbers, so other than these two. So and then that is our two smallest, which is 7. Okay. So think about like we have 6 window, right? In the house, like haunted house. So I'm gonna label those like windows. Let's say A, like B, C, D, E. So we have 5. And let's say the last one is F. So we have like 6 windows, and then we are gonna choose one of these windows and then to enter the house. And then we're gonna use one of these windows that is gonna be different from the one that we just used to exit, right? So like I have 6 choices, and then I can really kind of list them if I want to. I can start with like A, like this is the entering window. But as soon as you use A, you cannot go back with A to exit the house. You're gonna use one of the remaining, so I can choose B. Or I can choose C, or I can choose like D, I can choose like E, I can choose F. So which means if I enter from the window A, I can choose one of the other 5 windows, right, to exit. So and then A is not special. Like for A, we have like 5 ways. Like if I like enter from window A, then I have 5 different ways that I can exit. But A is not special. I can do with the same thing with B. So if I like enter from B, then I can exit from A or C or D or like E or F. So which means any window that we use to enter, we are gonna have 5 choices to use to exit. So instead of just keep listing this way, we are gonna say there are 6 choices to enter, right? And then as soon as we have decided one of these 6 options to enter, then we have 5 left for the exit, right? So that's gonna be 6 times 5, which is 30 ways we actually can do this. And you can always do this like 6 ways to enter from A and exit from any of the remaining. So that's 6, and then you have another for 6 for starting with B, and then starting with C, and then like start with D, start with like E, and then F, right? So if you do this, so you get actually we have 6. So actually these are all 5. I just tried wrong. So if I enter like from A, so I have 5 ways to n, 5 ways to n, all the way to the 5. So 6 of these 5s going on, so that's 6 times 5. So we don't want to list them anyway because it is gonna take too long if we have like more choices. So in this case, it wasn't the deal, but if you don't really see immediately, you can kind of start with listing, organize away, and then kind of see a pattern. And that's basically what we have, okay? So that was number 4. Okay, so this is also kind of straightforward, right? So we have a like bike, mountain bike that he wants to like purchase that is costing $500. And he's getting like 50 bucks from grandparents. So that's the amount we already have. And then he's getting 35 from his aunt. And then he's getting $15 from his cousin. And then he earns 16 bucks per week, right? So, but we don't know number of weeks, so that's what we are interested. So I'm gonna call this is X weeks. So each week he is earning $16. So I'm gonna say 16 times X. When you add all of these, that has to be 500 at least, so you can buy the bike. So if I add these two, that's 50. That's 50 right here. That's 100. So if you subtract 100 from 500, so that is just 400. And then I can divide by 4. So because this is divisible by 4, this is divisible by 4, that's gonna be 4x, and this is gonna be 100. And I can divide by 4 again. So 100 divided by 4 is 25. Or you can just immediately divide by 16, which is choice B. Okay, I think that was also straight. We are looking for the percent decrease, right? So that is like what we are interested. So to find the percent change, increase or decrease, in this case, decrease. So we need to find the change, the amount of decrease basically. So I will say change over the original. So we are looking for the percent decrease in the cost per minute, right? So the price was 41 cents per minute, and now it's 7 cents per minute in between those two different years. So the change is gonna be 41 minus 7. That is the change in cost. And if you are looking for a percent value, so you just need to compare this change compared to original number, so which is 41 cents. So if you take the difference, so that's 34 and divide by 41. So like at this point, you don't really want to do a division, like because 34 divided by 41 does not look like nice values, especially with our calculator. But you know, this is like 35. It's almost close to 41. And then 34 is like larger than half of this number. So which means this fraction is larger than 1/2. If this is equal to 1/2, that has to be 50%, but it's larger than 1/2. So, and then there's only one choice that is larger than 50%, which is choice E. But if you really want to kind of really do the fraction division, you can do that. So I want to kind of slightly do differently. Since we are looking for the percent approximation, so maybe I can consider as this is 40, right? And then this is like 34 still. So if I take this is 40 and then this is 34, then the percent value will be larger, right? Because we are making the fraction denominator a bit smaller. If you make it smaller, then actually you're making the percent a bit larger. So that means this has to be smaller than 34 over 40. So why I do care about 40? Because I can make that a out of 100 easily. So I can divide these two numbers by 2, so which gives me 17. And then this is 20. I just divide by 2 because I can multiply 20 by 5 to get 100. So if I multiply this by 5, so you will get 85. And if you multiply this by 5, you get 100. So 85 over 100 is just 85%. but our actual number was 34/41, not 40. So when we convert this number to 40, we made a bit larger than what we actually have. And our answer should be a bit lesser than 85%. 80 is actually a bit lesser, okay? So you can confirm that is the case. I just did this second part right here because if you had some choices, let's say, like, I don't know, 70 something, or I don't know, 90 something. So maybe 86 or 85. You can just kind of go with this kind of much better approximation. But in this problem, so it was really obvious that 80% was the case as soon as we have this fraction without really doing some approximation, okay? So that was number 6. So let's move on. So number 7, it says the average of the 5 people in a room is 30 years, right? And an 18-year-old person leaves the room, what would be the average of remaining 4 people? So like, since we know the average of 5 individuals as 30, so we can actually take their ages, each one of these 5 people as 30, like, even though it's not 30, because the average is 30. So some of them is larger, some of them is smaller than 30. But if I take the like 30 as for each person's age, their sum is gonna be 5 times 30. Because when you add the sum of the ages and divide by 5, you get 30. So if you want to find the sum, so that means the sum of the ages is 5 times 30, okay? So which is 150. So, but the question asks now, one person leaves, which has 18 like years old, right? So if you subtract 18 from when this sum, and now we have 4 people left. So to get the average of the remaining 4 people, we should divide by 4. So which is 132 over 4. And one quick reminder, in order for a number to be divisible by 4, the number that is formed by the last 2 digit, which is 32 in this case, should be divisible by 4. So 32 is a multiple of 4, so which means this number is divisible by 4, which is good. So if I divide 13 by 4, that's 3 times. That will be 12, and then 1 left over. So 12, 4 goes to 12 again, 3 times. So 33 as our final answer. So that was number 7. So you can just make some values if you want to. Like some people may want to choose like the age out of 5 people, let's say 18, and just guess 3 other numbers. That is gonna give us an average of 30. You can go with it as well, but this is straightforward. So let's get started. So the question says this is a ABC, this is a trapezoid. So like, if you remember, the trapezoid is a 4-sided figure where you have 2 opposite sides are parallel. So we are also told BE is parallel to AD. So this is AD and then this is BE. If these guys are parallel, so if this is 90, which will force this angle 90 as well. So this is also 90. So, and then I'm going to use these symbols to show they are parallel. So meaning that I cannot have AD and BC are parallel, so which doesn't look like anyway, which means if this is a trapezoid, so AB and DC are the parallel sides. Okay, so if this is parallel to this guy, and then this is 90, which will force A as 90 as well. Since we have all 3 angles 90, so B is also 90, which will force this guy AB, like A, B, E, and D is a at least rectangle. So since this is 3 units, so DE is also 3, AD is 3, so BE is also 3, which means this is actually a square, which looks already anyway. And we are told the C is 6 units. So now we know the DE has 3. So what's left over is 3 as well. So that should be EC. And now we want to find the area of the BEC. So we want to find this region. So this is a right triangle. And then if you want to find the area of a triangle, we just take the half of the product of the 2 sides that is next to the 90 degrees. In this case, like this is 3, this is also 3. So we can just take 1/2 of the product of those. That's gonna be 4.5. So one easy way to remember why we take the half of the product of the two sides in a right triangle is making this figure into a rectangle or square. So if you make this region, so the area of the BEC, which is a triangle, right triangle, is actually half of the area of this square. So if you want to find the area of the square or rectangle, you just multiply two sides. And since this is the area of the triangle, you just take the half of that product. So you can kind of think as that way as well. So that's the choice B. Let's see. So I think this is straightforward as well. So what we are given, let's read the question carefully. It says the 1 through 4 digits must occur once in each row and once in each column. And based on this, what will be the number that will be lower right-hand square? So, which is this one, right? If you look at the number that you have a lot, so you kind of start with those areas so we can actually find the missing ones. So in the first row, we have 1, we have 2. So if I want to find the number in this part, so that can't be 3 either, because if I want to choose 3, so there will be 2 3s in this second column, so which is why this can't be 3. So only way that will be completed, this has to be 3, and then this has to be 4, right? Okay, that is good so far. And we have 2 numbers in this column. Consider this point. So this point can't be 4, this can't be 3, and this can't be 2 either, because 2 is on the second column. So only way that will happen, this has to be 1, right? So if this is 1, then we have 1, 3, and 4. So 2 is the only missing number on this last column, which has to be our answer, so which is 2. So it wasn't too challenging to see, but the goal is just to find what you want without really completing everything. So start with the area, the column or row that you have some more values at least, and intersect with some other columns or rows to see the option. In this case, we had only one option for the first row, second column, and first row for column. In some cases, you will have more than one choices that will apply to either one. Then in those cases, we are going to go with each choice and see which one actually completes the other missing part as well. But in this problem, we don't have that kind of struggle, to be honest. Okay, so that was number 9. Okay, I'll go ahead. So the question kind of straightforward. It says for any positive integer n, define the square of n, if n is inside of a square. This is kind of the operation we are told is gonna be sum of the positive factors of n. And then we are told in example, we are given 6. If you take the 6 in that square, right? So you just add the divisor of 6. 1, 2, 3, and 6 are the divisor, and that's 12. So what we want is the value of this 11, but 11 is under 2 squares, right? So if I take the first one, let's say the first one is 11, right? So take 11 and put this guy under a square. So this means you add the divisor of 11. So if you add divisor of 11, so 11 is a prime number, so we have only 2 divisors, which is 1 and 11, so that is 12, right? So now we got the inside square, but there is another one, so this has to be equal to 12 now, right? So 12 is in another square. So now we want to find the sum of the divisor of 12, which you can immediately list them. So I will just say 1, 2, 3, 4, 6, and 12. So if you add this divisor of 12, so you will get the answer. So that's 18, 20, 24, 27, and plus 1 is 28. So this is the one way to find the sum of the divisors. Since like 12 is not a huge number, so we can just list the divisors and add them. But if you have a number that is actually a bit bigger, maybe 10,000, and then you want to find the divisor of 10,000, you don't want to really list them. So what we do instead, we have a shortcut adding the divisor. So we take, for example, 12, right? And then we want to write the prime factorization of this one, which is 4 times 3. So I can write as 2 squared times 3 to the first power. And this is going to be general approach for us to get the sum of the divisor. But in order for us to get the sum of the divisor, we just take the prime factorization and we use that prime factorization to add the divisors. How this is going to look like? We are going to start with any prime factors, like 2s and 3s is the only one. You start with, let's say, 2, right? So you take the 2 to the 0th power and then add 2 to the first power and add the 2 to the second power. Okay, so this is going to be stopping because your largest power of 2 was 2, which is why you're going to stop at 2 to the second power. And then you multiply this by the same approach with the 3s. So 3 to the 0th power and 3 to the first power. And then we are stopping at the first power of 3 because the largest power of 3 was 1. So, and if you add these, you get like 1, 2, and 4. And then this is 1 and 3. So the 0th power of any number is just 1. So that is 7. And this is 4. So if you multiply 7 and 4, you indeed get 28. So if you really like the second approach, go ahead and use it always if you are looking for this sum of the divisor. So, and we can make this even like formula type writing, but I don't think we need for now. And then I can prove why this actually works. So in order for us to get the sum of the divisors, we are gonna take the prime factorization and write the power of each prime numbers, starting from 0 all the way to the largest power of that prime in the prime factorization. We just multiply those sums to get the sum of the divisors. So this is not really what we need in this problem because like 12 is a small value. So we can kind of list them and add them, which is what we did already. But that will be useful. Let's say if I wanna, I don't know, take like 10,000, right? If I wanna take the 10,000 and if I wanna find the sum of the divisor of 10,000, I don't wanna list them because there are too many divisors. Instead, we are gonna take, this is 10 to the like 4th power, which means 5 to the 4 times 2 to the 4th power, right? And we are gonna use these guys like using similar approach. So I'm gonna start with, let's say, 5 to the 0, 5 to the first, 5 to the second, 5 to the third, 5 to the fourth. And then later, we are gonna actually find a easy way to add these as well. But for now, we are just manually add them. So 2 to the 0, 2 to the first, 2 to the second, 2 to the third, and 2 to the fourth. So if you combine these, you get like 1, 5, 25, 125, and 625. And the next one is 1, 2, 4, 8, and 16. So we have 625, and then if you add this, that's 650, right? And then 775, 780, 781, if I'm not mistaken, with adding. And then the next one is 16 and 4 is 20. So 28, 30, 31. So multiplying these two numbers are not like too challenging, right? So you can go ahead and multiply this. Whatever you get from this, that will be sum of the divisor. It's gonna be way like convenient than listing all the divisor because this number has 25 different divisors. And if I like wonder how do I get 25 divisors immediately, like how do I know there is 25? There is also a shortcut for that, but we will see that later as well, okay? But I just want to remind this approach for some of the divisor because that will be useful with larger values, okay? So anyway, so that was number 10. Okay, so there are a lot of ways to kind of look at this one. One of them probably is just try and error. So which will give you anyway the answer at some point. But instead, look at the numbers a bit carefully. Like I have like 3 right here, 3 right here, right? So which means this side and this side should be coincide when you translate. Coincide means like you're gonna be getting those on the same location. So translate means just move. So without really rotating and stuff. So if I want to take this 3, for example, right here, and this 3 will be right here as well. So that might be the case, or maybe like 3 will be right here because you will get those 2 intersection. That's one you can try. Like you can go with like if this is 3. So let's go ahead and try that first. If this is 3, then I could have 6 right here. I mean, 6 is this one, so 6 has to be here because this 3 and this 3 should coincide. So which will force this is 4 and this is 2. And that's gonna be our like number 2. Okay, and then this is 3, 8, 7. So this is 8 and this is 7 and this is 9. But let's see if this is possible. So since this is 2, there is only 2 right here. So which will force this to be 4. Right? So that means this is 9, this is 6, and this is 1. And this is 1. So this one is actually is good. So that is 7, which is a 7. And we have a 0 right here. And then 5 right there. So as you see, this is immediately correct answer. So this is my first try based on the 3s that I've seen. So you could just start with that, which you will see the answer anyway, right? So but that's one thing we can try, right? So we can just say rectangle C was this one, which is the number 2, right? So 9, 2, 1, 6. No, 9, 2, 1, 6, number 4. So that is the choice 2. So if you don't see this immediately, I don't know, you can go with the choices. Let's say try choice C and plug it right here and see if the other numbers actually align. And based on, you can go with any choice to eliminate. But I think that was one thing we can try. And second thing I can try, like, you know, this is 1, then this is 1. So you can try taking this side and like putting next to this one. So we can get ones are coincide, either the top row or the second row. So you can try either cases and that will give us the answer anyway. So that was number 11. Okay, so we are given a unit hexagram, like hexagram, right? It's composed of a regular hexagon. So regular means all the sides are equal as well as the interior or exterior angles. So the side length of 1 and 6 equilateral triangle extension. So what we are told, like this side is 1, and then this is also 1. So all these guys are 1s, right? And you can continue. And then there are 6 equilateral triangle extensions. So meaning that this is also 1, this is 1, this is 1, this is 1, and stuff like that. So what we want is the area of the extensions, to the area of the original hexagon. So original hexagon is the one in the middle, right? So since this is a regular hexagon, so which means it's all nicely symmetric. If you take the center of the hexagon, right? So and then if you connect this point to each vertex, so you will actually see nice relations. So if I connect these guys, and then that would be giving us 6 equilateral triangle. How do I know they are gonna be equilateral triangle? Because like since this is regular hexagon, when you take this center point and connect with each vertex, the central angle right here is actually divided into 6 equal pieces. If you divide 360 by 6, so that should be 60 degrees, meaning that this is a 60 degrees, and this is 60, and this is 60, this is 60. These are all 60s. So we know that this distance and this distance are equal, because that's the distance between the vertex to the corner for a regular hexagon, so it has to be equal. And if this is 60 and then these two are equal, this is going to be forcing this is to be a isosceles triangle. So if you subtract from 180, you got 120. So that means this is also 60 and 60, because that's going to be half of 120 for the remaining part. So then the same reason with all others, right? So we have equilateral triangle, but this equilateral triangle and this equilateral triangle has the same segments, right? So meaning that if I name this is 1A, then this is also 1A. And the same reason, this is A, and this is A, this is A, this is A, this is A in terms of area. We have like this is A, this is A, this is A, this is A, and this is A. So the extension, we have 6 copies of those, so which is 6A. And divide by the original hexagon. Original hexagon is a hexagon with 6 equilateral triangle as well. So that is 6 to 6, so which is choice A. Okay, so that wasn't too challenging. We never use any like advanced tools. We just look at the given statement and use that regular for our advantage. So that was the case. We can even find the area of each triangle, which we don't really need, because at the end we are dealing with a fraction. Okay, so we are going to cancel those. So that was number 12. I'll move on. So the question are telling us, the question is telling you like the sets A and B are given as a Venn diagram have the same number of elements. So which means the number of like whatever is in the circle is the same as number of whatever in the second circle. Okay, so number of elements. So if that's the case, let's say that number is X. So I'll say the number of elements in A, which is N of A. I'm gonna call this is X, and then this has to be same as number of elements in B as well. Okay, so but the X is the total number in this entire circle, and then the 1001 is in the middle region, which is the common region. So if I kind of wanna combine everything, so I can say X is the value in this circle. So I will say plus the another X in the second circle. But when I do this, X, this covers this middle region. When I do this, this covers middle region as well, which means this 1001 is counted twice, which is why I have to subtract that 1001, because when I say X, that is taking this 1001 as well. And when I say second X, that is also taking this 1001, which means we are over counting. So now if you subtract one of these 1001, so you just actually add everything once. And then we are told this is equal to 2007 elements. And if you solve this equation, you will get the X as what you want, because we are looking for the number of elements in A, which is X. So I will say 2X. Right, and if you add 1001 to both sides, so you will get 3008 and divide by 2. So half of 3000 is 1500, and then half of 8 is 4, so that should be 1504 as your choice C. So this is something we have, but we never use any formula or any fancy looking stuff. But if you really want to write a general like approach, maybe a formula or equation, this is what we can say. The X was the number of elements in A, right? Which I use this notation. I'm gonna say N of A plus the second X is the number of elements in B, which is N of B. and minus the region in between those two sets, which is 1001 in our case, but we have a special notation which we use A intersection B. So when you use this like N, capital N, that means intersection, which means this region. Okay, so this region is intersection. And then we use as N of N A intersection B, this notation. So that is just this region. Okay, so when you combine these three, this is equal to N of A union B. So union is just the notation we use, like capital U. Union means just combine everything basically. This is exactly what we did when we do this equation, but we never use any equation like that. And then this equation has a name we call like pi. Pi means like principle of inclusion and exclusion. So if you have two events, in this case, like we have A and B, like two sets. So we have NOA plus NOB minus NOA intersection B, because that middle region was counted twice, so we have to fix the overcounting by subtracting the intersection, and that will be equal to the sum of the elements in either sets. Okay, so that was a union. So again, we don't really need that red part. I just wrote it because sometimes it will be way easier, and now we can just kind of get that immediately when we use that. Okay, so that was number 13. Like we are given a isosceles triangle, right? So it's good to visually see how that looks like. So which is why I'll draw a like figure, and it doesn't have to be a correct figure, right? So let's assume these two sides are the one that is equal, because we are told this is isosceles. And if I have the information of base of 24, so which will be this side, right, 24. And we are given the area, you know, the area of a triangle in general, we just take the base and multiply by height and divide by 2, right? This is the area formula for any like triangle in general. So we know the base, which means we do need a height, which we don't know. So, but we are given the area. So if I drop the altitude from this vertex to other side, so that will be my height. So now if I want to say the area is given 60, which is this one is 60, and the base is 24, and height I don't know, but I can find, divide by 2. So what we now want to do is just solve this equation. So I can simplify this as 60 is equal to 12, 24 divided by 2 times h. So divide by 12, so you will get 5 for h, but we are looking for not the height. So as you see, choice A is 5, and some people may want to go with that, but that's not what we are looking. So we are looking for the length of the one of the congruent sides. So which means we are looking for this side or that side. So since this is isosceles triangle, right? So then the base will be split into two equal pieces. So meaning that this is 12 and this is 12. And there is now a right triangle. So if I name this, let's say A, like B and C. So maybe this is H. So the triangle AHC or AHB is a right triangle. And the side that is opposite to 90 is what we are interested in. And since we know that this leg is 5, this leg is 12, the hypotenuse should be larger than 5 and 12, meaning that these two can't be answered. Okay, so you can meet across those. And the rest just using the Pythagorean. If you remember the Pythagorean, so the Pythagorean is a relation we have when we have a right triangle. So the sum of the squares of the legs is equal to square of the hypotenuse, right? So the hypotenuse is the one that is opposite to 90. In this case, I will say that's AC. The other two A and B doesn't matter. So you can take this leg as A and this leg as B. So you will get 5 squared plus 12 squared. And this is 25. This is like 144. And that will be equal to AC squared, right? That's add up to 169 equals AC squared. The square of AC is 169. If you remember some of the perfect square, this is actually 13 squared. So take the square root. So the AC is equal to 13 or negative 13, but it doesn't count with the negative because that's the side. So that's the choice C. So here's the like quick reminder. Like I did the Pythagorean, right, to get my missing side as like my answer. But as we go, we are gonna see a lot of Pythagorean like triples will be useful. The Pythagorean triple is just a 3 values that satisfy the Pythagorean. And then we have some of them are really common, which is why I just want to highlight some of them. So one of them is like the Pythagorean triple. So maybe I will just write here. Pythagorean triple. So the most famous one is 3, 4, 5. So if I have 3 and 4 as two sides, the hypotenuse will be 5. If you are given any of these two numbers, you can tell the third one immediately based on the given sides. And the second Pythagorean triple that we see a lot is 5, 12, and 13. Because as you see, this is 5 and this is 12. So if you remember this one, then you actually could skip this Pythagorean. So you can say this immediately 13. That's the second important Pythagorean triple. And then we have like 8, 15, and 17. So that's another Pythagorean triple. So if you know the legs are 5 and like 8 and 15, the hypotenuse is just 17. Or if you know hypotenuse 17 and one of the legs is 15, then you can say the other leg should be 8. So try not to just memorize them, but you're gonna see this a lot. Just try to recognize them. So if you like try, so you will actually remember those. And another one we have 7, 24, 25. So these are the 4, I guess, mostly common used ones. But we have more than these. We have actually infinitely many Pythagorean triples. So just start with these 4 for now. And then as you go, you will explore more, okay? So let's see the number 15. Let's start with. So we are given ABCR numbers, so they are like some real values, right? It doesn't have to be integer. And 0 is smaller than A is smaller than B is smaller than C, which means A, B, C are all like positive numbers, right? Which is kind of easier to deal with. And which of the following is not possible? So if you look at the choice A, it says A plus C. A is the value larger than 0, but smaller than C. And then when you add A and C, you add 2 positive numbers. It says smaller than B. Like it's not possible because we know that B is smaller than C. So like even though you don't have A in our equation, C smaller than B is incorrect. And then we know that A is a positive number, right? So which means that will increase the value of C a bit. And then that means the left side of this inequality will be way bigger than B. So which is why this choice is incorrect. There is no way to get this result. But let's look at the other choices, right? Just to make sure. A times B is smaller than C. Like if I choose this is 1, this is 2, maybe this is 5. So A times B is 2 smaller than 5. As you see, this is achievable, okay? For the second one, I can say 1 plus 2 is lesser than 5, which is 3 lesser than 5. That is also achievable. And for the D, like 1 and like 5, like when I try these numbers, that does look like this is wrong, but doesn't mean that is wrong because I just choose those 2 values. I can choose anything else. And let's try this as well, but it doesn't work that way either. So let's choose something else. When I choose 1, 2, and 5, as you see, I was able to eliminate at least 2 choices. So that was achievable. That was achievable. And let's try something else. It says B over C is A. So maybe B over C is equal to A. But how this is possible, right? Like if I choose a value of B and divide by C, and then that will be A. That could be possible, right? So if I choose like this is 4, let's say this is A, then that will be 4 over 8, which is 1 over 2. 1 over 2 is a positive number. So that means E is also possible, right? And C, A times C is lesser than B. That is also possible because if I choose like A is 1, and let's say choose C as like 3, if I choose 3, then I should have this product A times C is smaller than B, right? But if I choose 1, it does not work. But if I choose, let's say 1 over 2, because it could be anything, right? So, and then if I choose C as like 4, right? That means A is 1/2, C is 4, the product is just 2. So the B has to be larger than that. So I can choose B as 3, which does work now. So, which means this is also achievable. So as you see, anything but A are possible, but the others are not, okay? I mean, yeah, everything but A is possible, so A is not possible, okay? So that was the choice A.